Today the notes are 7.3a. We will be solving rational equations by cross multiplying. Whenever you have one fraction on each side of the equal sign, you can cross multiply and get rid of your fractions and solve. The one thing that we have to remember though is that any time you could possibly get a 0 in the denominator, that will not work because it would make the problem undefined. So what they mean by extraneous solutions is that 0 in the denominator of the original problem would give you an extraneous solution, a value that will not end up working. So if you set each of these denominators equal to 0, on this one, 5x equals 0, you divide by 5, x equals 0. 0 is an extraneous solution. Here, x minus 7 equals 0, you add 7, x equals 7. So 7 is also an extraneous solution. So if when you are solving this problem, you end up getting 0 or 7, that answer will not work. So on example 1, cross multiplying means we are multiplying our diagonals together. So that means, I'm going to write this out, we have 3 times x minus 7 equals 2 times 5x. And then now we're just solving. So we distribute the 3 through and we get 3x minus 21 equals 2 times 5x is 10x. To solve for x, I subtract 3x to both sides. Negative 21 equals 7x. And lastly, we divide by 7 to both sides to find that x equals negative 3. And negative 3 is not an extraneous solution, so we're good. Okay, example 2. What would my extraneous solutions be on this one? So for x minus 1, if I set that equal to 0, an extraneous solution would be negative 1. 4x plus 5, if you can't do that in your head, just write it out. 4x plus 5 equals 0. Subtract 5, 4x equals negative 5. Divide by 4, so my extraneous solution is negative 5 over 4. So now we need to check to find the actual answer for x. So we are cross multiplying. So we have 3 times 4x plus 5 equals, and we have 9 times x plus 1. So now if we go through and distribute, we have 12x plus 15 equals 9x plus 9. We solve by subtracting 9x to both sides. And I can go ahead and subtract 15. So 12x minus 9x is 3x equals, and 9 and negative 15 is negative 6. Divide by 3 to both sides, and I have x equals negative 2. And again, double check. It doesn't match any of my extraneous solutions, and therefore that is the correct answer. Okay, example 3. So hopefully you can figure out what your extraneous solutions are on this one. Again, you can set them equal to 0 if you're not sure, but in my head I know I'd end up moving the negative 5 over and dividing by 2. So that means an extraneous solution is negative 5 over 2. On this one, I would move the 8 over, making it a negative 8, and then I'd have to divide by 11. So those are my 2 extraneous solutions. So now when I cross multiply here, I have x times 2x plus 5, and then equals 1 times 11x plus 8. When I distribute, I get 2x squared plus 5x equals, and 1 times anything will just be itself, so we have 11x plus 8. Since I have a squared term, that means we want our squared term to be positive, so I'm going to move everything to the left. So I'm going to subtract 11x, and I'm going to subtract 8 to make it set equal to 0 so that I can factor. We have 2x squared. 5x and negative 11x is negative 6x minus 8 equals 0. Always check for GCF. In this case, my GCF is 2, so I have a 2, and when we factor, we get x squared minus 3x minus 4 equals 0. X squared minus 3x plus minus 4 can be factored. So what multiplies to be negative 4 and adds to be negative 3? X goes in the front. It's going to be 4 and 1, and it'll be a negative 4 and a positive 1 in order to make a negative 3. So when we set those equal to 0, we end up getting x equals 4 and a negative 1. If you set 2 equals to 0, 2 equals 0, that doesn't make sense, so that one's out. And then when x minus 4 is equal to 0, you get 4 plus 1 makes a negative 1. Check your extraneous solutions. None of them match. That means that both of these answers are correct. All right, last example. This one is a little bit more complex because you need to factor it first. Well, yeah, I would probably, no, actually, you do not need, oh yes, you need to factor it first, I'm sorry. And the reason we have to factor it first is in order to find our extraneous solutions. So if we factor this one, we get x minus 3 and x minus 3. Those multiply to be positive 9 and add to be negative 6. Here I have to take out an x and an x minus 3. My GCF was x. And so my extraneous solutions, when I set x minus 3 equal to 0, that's 3. And then when I set x equal to 0, that's 0. And then that's 3 again, so I don't have to write it multiple times. So my extraneous solutions are 3 and 0. So now for cross multiplying. You have to end up multiplying this back out, so go back to how it originally was. So when I write my cross multiplying, I have 3x times x squared minus 6x plus 9 equals, and then we have 9 times x squared minus 3x. So we distribute, and we get 3x cubed minus 18x squared plus 27x equals, and we distribute, and I have 9x squared and a negative 27x. So this is my highest exponent, x cubed, so I'm going to move this stuff to the left. So I'm going to subtract 9x squared, and I'm going to add 27x. So those cancel, and we have 3x cubed minus negative 18 and negative 9 make negative 27x squared, and then 27 and 27 make a 54x, and this is now set equal to 0. So we can take out a GCF. In this case, I can take out a 3x, which means I'm dividing each of these by 3x, and that will leave me with x squared minus 9x plus 18 equals 0. Then we can factor further. So we have 3x, and we get what multiplies to be a positive 18 and adds to be a negative 9. So hopefully you got that, and that would be 6 and 3, both of them being negative. Those add to be negative 9, multiply to be positive 18, and this equals 0. When we set each of these factors equal to 0, 3x equals 0, divide by 3, and we get x equals 0. Here we get x equals 6, and then x equals 3. So we check our extraneous solutions, and 3 is an extraneous solution, and 3 is here, so this will not work. Over here, 0 is an extraneous solution, 0 is an answer, 0 will not work. So that means the only answer can be x equals 6. And that is the end.